Hey guys, so we're going to take the integral from 0 to 1 of x times the square root of x times the cube root of x, and so on. So we're going to take an infinite amount of nested radicals, but instead of radicals, we want to put fractional exponents. So we're going to replace them by doing the integral of 0 to 1. This stays as x. This is x to the 1/2. This is x to the 1/2 times 1/3. This is x to the 1/2 times 1/3 times 1/4, and I'll write it like this to make the notation easier. And you probably see a pattern developing. There's basically a factorial in the denominator of each of these exponents. There is no times 1 at the end, but we can basically see it'll be factorial, so on and so forth. So instead, we're going to rewrite this in the form of factorials. 1/2 factorial, 1/3 factorial, and that's going to continue indefinitely. Now, instead of writing them with separate exponents, we'll combine them as a sum of exponents under one base. So that becomes 1/1 factorial plus 1/2 factorial plus 1/3 factorial, and so on infinitely. Now this series looks familiar, and it should, because the series from 0 to infinity of the reciprocal of its factorial is equal to e. However, realize we start from 0. Here there is no 0 factorial, so we need to add that 1/0 factorial, and to compensate we need to subtract 1. So instead we write x, I'll subtract the 1 first, and in parentheses 1/0 factorial plus 1/1 factorial plus 1/2 factorial all the way to infinity. So we've established that that little sum of the parentheses is equal to e, so that we get x to the e minus 1. So we take the antiderivative, which is just adding 1 to the exponent and then taking that as a fraction as well. So we get 1/e times x to the e from 0 to 1. If we plug in 1, that gives us 1/e, 0 gives us 0, and our answer is 1/e.